All right, this is the 13B. It will be electrostatics. Just for any of the assignments and announcements, check the introductory video. The big question for today is what is cold? So this is the weekly plan that I go over in the introductory video. Just make sure you turn in those three things at the end of the week. And there are codes in the video. One will be written, the other will be verbal. Each code will be 3 numbers. So when you're taking notes, just write what is in green, or if I tell you something like a table, that'll make things simpler, just put that into your notes. And this is the 13B written code. I would recommend writing this down somewhere. All right, so let's just talk about the electron. So the classic view of the atom is like the miniature solar system. However, there's a huge problem with this model. It could not be stable. Atoms could not exist. Now, if electrons were in orbit around the nucleus, like a planet, then atoms could not exist. They would not be stable. The electron would be accelerating, it would be emitting radiation and be lose its orbit. Right? So it would gradually spiral. It would lose energy because as it's accelerating, it would emit light. So 1913, Niels Bohr proposed his quantized shells model of the atom to explain how electrons have stable orbits around the nucleus. So they don't really orbit, they're just sort of in energy states. Now, according to Bohr, the electrons just couldn't be anywhere. They could only be located at certain distances from the nucleus, and we say that electron orbitals are quantized. Now, how did he come to this remarkable conclusion? Well, I posted a video that shows this, right? So you can put different gases through a charged electron beam or a electric beam, and it will emit that spectra. So only certain energies, colors, right? So photons are absorbed or emitted. Energy must be quantized. So electrons only allowed to orbit in particular levels. Photons emitted as electron jumps from a higher level to a lower level. So electrons will emit as they go down, but photons are absorbed as electron jumps from one lower level to a higher energy. So you put energy into something, it's going to jump up a level and it will emit a photon, and you can see what element that is based on the color of that photon that was emitted. So the Bohr model is the one that we are going to use in this class, but keep in mind the Bohr model is really inadequate in describing the atom. The quantum model of the atom does a better job of reflecting how electrons orbit around the atom. So you can see here, this is the quantum model that Erwin Schrödinger came up with. And this just shows like, yeah, electrons have a probability of being somewhere, but they're not orbiting around the atom. So that brings us to temperature. And temperature is a measure of the average kinetic energy of the atoms and molecules. So kinetic energy, the energy of motion. A thermometer measures how fast the atoms and molecules are moving. Thermometer is like a molecular speedometer. Measures the average speed of the molecules of a substance. And if you want to look at temperature, just look at that simulation, and that'll show you how the different atoms move. But that's all temperature really is. So we talked about states of matter. So these should be in your notes. So we learned about solids, liquids, gas, and plasma, and there are different examples down here. And you should know whether they're rigid, fixed shape, or fixed volume. So these are the first three states of matter you should have come up with and what we know. To convert from one state of matter to the other, energy must be added to the system. If you look at your notes, you will notice that two states of matter appear to be the same. Right? In fact, the state of matter on the left, the state of matter is left off the diagram to the right. So that brings us to another question. What is plasma? So plasma is the fourth state of matter. Plasma is nothing more than ionized gas. Plasma state, electrons have been ripped off atoms, and we just have a soup of free electrons and positive ions. The most common state of matter in the universe. So plasma can be produced not only by heating a gas, but by placing the gas across a very high voltage, as in that example that's up there, and you've probably seen one of these orbs. That's plasma. So at this time, I'll go ahead and give you the 13B verbal code. It is 395. I say that again, the verbal code is 395. I'll go ahead and give you the links for the day. You can see there's a lot of different videos that you can see, a lot of activity simulations that you could watch in order to get to understand this a little bit better. And as always, I'll leave you with my final thought. There's just too much unknown in the universe to take a break from learning. Get out there and question everything.